Why most A-frame additions leak within 3 years, and how to build one that won't. They spent $40,000 on this A-frame addition. 18 months later, it started leaking. By year 3, we were tearing apart both roofs, dealing with water damage that had spread into the walls, and the frustrating part, this was 100% avoidable. If you're thinking about adding an A-frame addition, also known as a gable roof or a dormer, to your existing home structure, or you've already got one and you're seeing stains, feeling drafts, or noticing ice dams, what I'm about to show you could save you tens of thousands of dollars and years of headaches. The problem isn't that A-frame additions are risky. The problem is that most contractors treat them like regular roof installs when they're actually forcing two completely different systems to work as one. Just last month, I got a call out to a home in Basking Ridge, a beautiful property, a gorgeous addition built in 2021. The homeowner started noticing ceiling stains in the original part of the house, right near where the addition tied in. When we pulled back the shingles, we found rotted sheathing, soaked insulation, and a valley that had been installed with standard 12-inch metal and no ice and water shield. The water had been running under the shingles for years, silently destroying the structure. That's a $15,000 repair on top of a $45,000 addition, and it all came down to 3 mistakes that should have been caught during the planning phase. 1. The valley problem. According to research published by the National Roofing Contractors Association, steep pitch roofs, that's anything over an 812 pitch, can increase water velocity by 300 to 400% compared to standard 412 pitches. When that steep roof dumps into a valley at a lower pitch intersection, you're concentrating massive volumes of water into a single channel. Think of it like this. Your existing roof might be a 412 or 512 pitch, pretty standard for most New Jersey homes. That roof sheds water at a predictable rate. But an A-frame addition, we're talking possibly 1012 or 1212 pitches, sometimes steeper. The water doesn't just flow off, it accelerates. When all that water hits the valley, where the new roof meets the old roof, it's like turning a garden hose into a fire hose. The volume is exponentially higher. Here's what most contractors get wrong. They use the same valley materials and methods they'd use on a standard roof. Standard 12-inch valley metal, standard felt underlayment, maybe one course of ice and water shield if you're lucky. But that's not even close to sufficient for the hydraulic load an A-frame creates. You need wider valley metal. I spec 18 or 24 inches at least on these projects. You need a continuous ice and water shield covering the entire valley and extending up both roof planes. And you need to account for debris accumulation because those valleys are going to collect leaves, shingle granules, and ice like crazy. What this means for you, if you're getting quotes and the contractor isn't talking about oversized valley protection, extended underlayment, and specific plans for managing that concentrated water flow, they don't understand what they're building. And you're going to pay for that misunderstanding in 18 to 36 months when the leaks start. The key thing to understand is that valleys on A-frame additions aren't just architectural features. They're hydraulic systems under extreme stress. The difference between a valley that works and one that fails comes down to understanding the forces at play and engineering your materials to handle them. Standard approaches don't cut it. You need to think bigger, layer deeper, and protect wider. Number 2, framing integration. Let me explain what I mean by framing integration. When you're adding a new steep pitch roof onto an existing home, you're not just laying new rafters on top of walls. You're connecting two different load-bearing systems, the original roof structure and the new addition, and they have to work together as one unified system. If the load path isn't continuous, if the rafters aren't aligned with the existing ceiling joists or trusses, if the ridge boards don't tie in properly, you're creating uneven stress distribution. Think of it like building a bridge between two buildings. If the support beams don't line up, the bridge is going to sag or twist over time. Same principle here. I see this all the time. The contractor will frame the addition based on the floor plan without considering how the roof load is going to transfer through the walls and into the existing structure. The result? You get rafters bearing on walls that weren't designed to carry that load. You get ridge beams that end in midair with no proper support. You get ceiling joists that are undersized for the new span. And here's the sneaky part. This doesn't always show up right away. The roof might look fine for a year or two, but as the materials settle, as snow loads accumulate, as the wood dries and shifts, you start seeing sags in the ridgeline, cracks in the drywall, doors that won't close properly. Those are all signs of structural movement, and it's because the framing wasn't engineered correctly from the start. Here's what you need to ask your contractor. Are the new rafters aligned with existing load-bearing walls? Is the ridge beam properly supported with posts or engineered connections? Are ceiling joists sized appropriately for the new span. If they can't answer those questions with specifics, structural calculations, rafter sizing, and connection details, then they're guessing. And you don't want someone guessing with your home's structural integrity. In other words, proper framing integration isn't about what looks good when the project is done. It's about how the entire system behaves under load over decades. The work that matters most is the work you'll never see once it's finished. Number 3, ventilation continuity. Here's what's supposed to happen in a properly vented attic. Cool air enters through the soffit vents at the eaves, flows up along the underside of the roof sheathing, and exits through ridge vents at the peak. That continuous airflow keeps the attic temperature closer to the outdoor temperature, prevents condensation, and stops ice dams from forming in the winter. It's a simple, elegant system as long as nothing interrupts it. But when you add an A-frame addition, you're often cutting into that airflow path. Maybe the new addition blocks the existing ridge vent. Maybe the framing creates a dead zone where air can't circulate. Maybe the contractor didn't think to extend the soffit vents into the new section. So now you've got ventilated space on one side and sealed space on the other. Any of those scenarios creates a problem. Heat buildup degrades your shingles from below, shortening their lifespan. Moisture buildup condenses on the cold sheathing, leading to mold, wood rot, and rusted fasteners. Both of those problems are invisible until they're catastrophic. I was on a job 2 years ago where the homeowner had added a beautiful A-frame master suite. Gorgeous work, custom windows, vaulted ceilings, the whole 9 yards. But the contractor had framed the cathedral ceiling without thinking about how it connected to the existing attic space. No ventilation channel, no airflow, no communication between the old and new sections. Within 18 months, we had mold growing on the sheathing in the original attic and ice dams forming on the new addition. The fix required tearing out ceiling drywall, installing baffles, and cutting new vents. $12,000 in repairs that should have been handled during the original build. What this means for you: your contractor needs to map out the entire ventilation system before they start framing. Where is the air entering? Where is it exiting? How does the new addition integrate with the existing attic space? If they're not talking about baffles, ridge vent extensions, soffit continuity, and airflow calculations, they're not thinking about this, and you're going to have problems. The deeper principle here is that roofs aren't just about keeping water out. They're about managing heat and moisture as a system. When you add an A-frame that disrupts that system, you don't just need to patch it back together. You need to redesign the airflow so both sections work in harmony. Number 4, material integration. Let's start with the obvious issue: aesthetics. You've got an existing roof that's maybe 10, 15, or 20 years old. The shingles have weathered, the color has faded, the granules have worn down. Now you're adding a brand new section with fresh shingles, and unless you're doing a full roof replacement at the same time, you're likely going to have a visible color mismatch. What happens in 10 years when the old section fails? You're either doing a partial replacement again, which means another tie-in, another color match issue, or you're replacing the whole thing and effectively throwing away 20 years of life on the addition shingles. Same thing with underlayment, flashing, and ventilation materials. If your existing roof was built with felt paper and the new addition is getting synthetic underlayment, you've got 2 different moisture management systems. If the old roof has aluminum valley flashing and the new section has copper, you can get galvanic corrosion where the metals meet. These aren't just theoretical issues. I've seen these failures in the field. The real reason here is that material choices ripple forward in time. What seems like a minor mismatch today becomes a maintenance headache a decade from now. What looks acceptable at installation becomes glaringly obvious as the materials age at different rates. Thinking through material integration isn't about being picky. It's about protecting your investment and avoiding future regret. Number 5, sequencing and coordination. Here's what I mean by sequencing. A roof tie-in isn't a linear process where you just frame, sheathe, waterproof, and shingle. It's a choreographed sequence where each step has to integrate with what came before and what comes after. I'll give you a real example. I was called in to consult on a project where the contractor had already sheathed and shingled the new A-frame addition, and the homeowner was noticing that the ridge line didn't look straight. When I got up there, it was obvious the rafters weren't aligned with the existing ridge, and the whole addition was bowing. But because they'd already closed everything up, the only way to fix it was to tear off all the shingles, pull the sheathing, sister in corrective framing, resheathe, and reshingle. Thousands of dollars in rework because they didn't verify alignment before they committed to the sheathing. The correct sequence for an A-frame tie-in looks like this. First, you verify the existing structure. You check for sags, rot, undersized members, and load path issues. If there are problems, you fix those problems before you build on top of them. Second, you frame the addition and tie it into the existing structure with proper connections, alignment, and load transfer. You get an inspection or at least a third-party review to confirm it's right. Third, you sheathe the new addition, making sure everything is properly supported and aligned. Fourth, and this is critical, you install your underlayment and ice and water shield in the correct order. Valleys get layered protection. Eaves get ice and water shield. Synthetic underlayment goes over the field. Everything overlaps correctly so water can't work its way under. Fifth, you install your valley metal, step flashing, and penetration details. Sixth, you shingle, and you shingle in a sequence that maintains proper overlap and water shedding. Finally, you install ridge vents or other exhaust and confirm airflow. If you skip a step, reverse the order, or try to shortcut the process, you create failure points. This is why I'm so obsessive about process and why I walk my crews through the sequence on every tie-in project. What you need to ask your contractor: what's your step-by-step sequence for this tie-in? How do you verify framing alignment before sheathing? How do you layer your underlayment and flashing? What's your inspection process at each stage? If they can walk you through it with confidence and specifics, they've done this before. If they're vague or dismissive, they're winging it. To put it simply, proper sequencing is the difference between a roof that's built right and a roof that looks right. Anyone can make it look good for the final walkthrough, but only someone who understands the order of operations can make it perform right for the next 20 years. Look, if you're watching this and thinking, I'm planning an A-frame addition and I need someone who actually understands this stuff, or if you've already got an addition and you're seeing problems, I want to help. This is exactly the kind of project where experience and attention to detail make all the difference. If you want a free assessment where we'll walk the existing structure, review your plans, and give you an honest breakdown of what it's going to take to do it right, our link is in the description. No pressure, no sales pitch, just straight answers from someone who's done this thousands of times. All right, let's recap the 5 critical failure points in A-frame additions. 1. Valley engineering. You've got to handle this 6x water concentration with oversized metal, extended underlayment, and proper debris management. 2. Framing integration load paths have to be continuous, aligned, and structurally sound, or you're going to get sagging and stress. 3. Ventilation continuity. If you block the soffit to ridge airflow, you're creating mold, rot, and ice dams that won't show up until it's too late. 4. Material integration. Mismatched shingles and incompatible materials create both aesthetic and performance problems you need to plan for up front. And 5. Sequencing the order of operations determines whether your addition lasts or leaks. Now that you understand the 5 ways A-frame additions fail and how to build one that won't, you need to know how to find a contractor who's actually capable of executing this level of work. If you're seeing stains, leaks, or anything we talked about today, don't wait. These problems only get more expensive over time. Click the link in the description, and let's take a look before a small issue turns into a full tear-off.